On August 20, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system – Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us, about 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right. NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays, and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love. and it's an exceedingly small part. So you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So when we say, "banana is yellow," it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great, in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on a planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take. Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future.
Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy, colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find 2 human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light-years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda Galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, in another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. the key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects, but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.
Behold a city-sized power plant built by robotic spiders floating in orbit, transporting energy down to Earth as a beam. To us, it sounds like a crazy sci-fi idea, but for engineers, it's a very real project. The pieces are being tested, and space agencies want to have the whole system online in less than 30 years. Now, it wasn't that long ago that large-scale solar power felt unrealistic. Today, it's widespread and the most affordable form of energy. The biggest solar power plant on the planet, the Golmud Solar Park, has almost 7 million solar panels, and it could produce an unbelievable 2.8 gigawatts of electricity. That's enough to power more than 2 million homes and about twice the energy needed to power the DeLorean time machine from Back to the Future, if you're keeping track. Now, all this sounds great on paper, but in reality, it's a major headache. Large-scale solar power takes up massive amounts of land and needs constant upkeep. More importantly, solar panels on Earth never hit 100% efficiency. Our atmosphere acts like a pair of dirty sunglasses and scatters roughly 30% of the sun's energy before it even reaches the glass. Also, sunlight is unreliable. Remember those puffy things called clouds? Solar panels are like employees who take sick days when it's cloudy, barely work during winter, and sleep every single night. Hey, I had a job like that once. To keep the lights on at night, we have to rely on massive battery systems to cover that gap. Well, that's why engineers started looking for a loophole, or better said, a better location. If you travel about 22,000 miles straight up, you reach a geostationary orbit. This is the cosmic sweet spot. Up there, a satellite stays fixed over the same point on Earth. You get unfiltered sunlight non-stop every single day for a year. Well, almost. Twice a year, around the equinoxes, Earth slips in front of the Sun and throws a shadow across that orbit, creating a short blackout that can last up to 72 minutes. And then the sunshine is back on as if nothing happened. Well, finding a reserved parking spot in a 22,000-mile orbit isn't the hardest part. It's building the thing to do the work there. Depending on the design, NASA wants the structures to be anywhere from a couple of miles to nearly 6 miles across. We can't fit something like that on a rocket. The ISS is about the size of a soccer field and took more than a decade and over 40 launches to assemble. So, engineers are flat-packing it like IKEA furniture. The plan is to launch thousands of identical ultra-thin squares of mirrors and electronics, stacked like dinner plates inside a heavy-lift rocket. Something like this would be impossible for humans to assemble. It would take centuries of going up and down. That's why it's a job for little robots that might look like spiders, crawling over a giant metal web, snapping modules into place until the structure grows into a floating power city. But once the station is assembled, the coolest part is the delivery. You can have a massive amount of electricity stuck in orbit, and they don't really make extension cords and cables that reach up that far. So, engineers would have to turn that electricity into a beam. The station would convert the raw power into microwaves, or in some designs, low-intensity lasers. These are basically the same waves that heat your leftover lasagna. That beam is then aimed at a specific target on the ground. Wait, a beam from space? What if some bird gets in the way? That sounds like something from movies, where a giant laser fries a city. Well, actually, making and using that kind of weapon isn't unrealistic at all. It's just impractical, and the world lacks a proper villain. But this isn't a tight laser pointer. Over the distance that long, the beam naturally spreads and is designed to arrive wide for safety and control. So, by the time it reaches the ground, it's almost 4 times weaker than standing outside on a sunny day. And if a bird flew through the beam, it wouldn't go poof into feathers and smoke like in a cartoon. The whole energy beam from out of space isn't just a theory, and it's been tested. In 2023, Caltech's MAPLE experiment successfully beamed power wirelessly in orbit for the first time. They proved you can actually send energy through the void and catch it on the other side. On Earth, we catch it with a rectenna. That sounds high-tech, but visually, it looks like a giant fishing net made of wire mesh stretching for miles. It's not a slab of concrete and is, in fact, almost transparent, so much so that rain falls straight through it. That's because it doesn't need to reflect or block light. It's built to intercept specific microwave lengths. In theory, you could build multiple rectennas and switch targets as the station and Earth line up, like routing a call to a different tower. Right now, the Space Solar Project isn't waiting on some technological breakthrough. It depends more on a bunch of boring things getting cheaper at the same time. The biggest one is launches. A few decades ago, putting 2 pounds into orbit cost tens of thousands of dollars. Today, reusable rockets have cut that price by a lot. The more rockets fly, the cheaper each flight gets. Space Solar only starts to make sense when sending cargo to orbit feels less like a scary moon mission and more like basic freight shipping. The second piece is mass production. These stations aren't crafted like you need spacecraft. Instead, they're more like factories. They're made up of thousands of identical ultra-thin panels, all the same shape and size, with the same connections. It's the kind of stuff you mass-produce in millions, not something workers could assemble by hand. In the meantime, engineers also have to prove that everything can function on a small scale. The tests are already happening in bits and pieces. We're seeing small satellites, short power beams, and demos of autonomous assembly. NASA's own 2024 study models a path where the tech matures in the 2030s. The giant station gets assembled in the 2040s, and power delivery could start around 2050, which is not really that far. Also, breakthroughs can happen and push the project forward in an unexpected way. Now, building a project like this sounds wildly ambitious, but it's actually the first realistic step, just one of many bigger ideas that are still waiting in the far future. For example, what if you don't put the panels in Earth orbit at all? What if you put them closer in instead, where sunlight hits harder and every panel pulls in more energy per square foot? You build a station that lives in permanent daylight, then beams power outward like a lighthouse. One other idea keeps the same beam-it-down concept, but changes the build strategy. Instead of one giant city station, you split it into a whole constellation of smaller power satellites, like cell towers but in orbit. One satellite lines up over a rectenna, beams power down for a while, and then hands off to the next one, sliding into position. From the ground, it looks like a relay race in the sky. A chain of satellites marching around the planet, passing the beam from one to the next. And if one unit fails, the whole system doesn't go dark. The rest keep working, while robots swap in a replacement like a flat battery. And then we have the coolest and most famous one, a Dyson swarm. Not a solid shell, but a cloud of millions of collectors orbiting a star, grabbing a huge chunk of its output. If a civilization built that, the star itself could look wrong from far away, like somebody dimmed it on purpose. Any of these ideas belongs to a different era, when building a space is cheaper, easier, and maybe powered by technology we don't even have yet. But one thing is already obvious. From the moment we wake up, we're surrounded by devices that guzzle electricity, and we keep demanding more. So, it's not surprising that, slowly but surely, people are starting to look up at space as the next place to scale energy. For now, all we can do is wait for the next big upgrade. And maybe remember to turn off your devices when not using them. Just saying. Imagine a giant, immensely powerful storm rotating over your head. You'd be terrified if you could see it. But this storm is invisible to the unaided eye. It isn't your regular hurricane. This intense phenomenon happens in space. Space hurricanes are giant swirling storms that form not in our oceans, but up in the ionosphere. It's part of Earth's upper atmosphere charged with energy from the sun. Space storms look a lot like traditional hurricanes, except they're made up of plasma, supercharged gases, and instead of raining water, they rain electrons. These massive rotating hurricanes appear over Earth's polar regions. Now, think of a space hurricane as a giant funnel or whirlpool of energy spiraling over the polar regions. It's only visible from high altitudes or by satellites. Space hurricanes also produce cyclone-like auroras. Such colorful light shows look similar to good old auroras, but there's a big twist. Space auroras usually spin near the North Pole for several hours, raining charged particles into the upper atmosphere. Hurricanes on Earth are born from warm ocean water and low-pressure areas. They're fueled by Earth's rotation and heat energy from the ocean. Space hurricanes, on the other hand, are created by a different process altogether. They're influenced by magnetic fields instead of Earth's water. When the solar wind, a steady flow of charged particles coming from the sun, comes into contact with Earth's magnetic field in just the right way, it creates a kind of swirling vortex of energy high up in the ionosphere. It starts spinning, much like how a regular hurricane spins in the atmosphere. Now, let's go all the way back to 2014. That was the first time researchers spotted a massive space storm over the Arctic using satellite data. That hurricane was huge, but at that time, they didn't know exactly what it was. What they did know was that its base stretched over 600 miles in diameter, and it had multiple spiral arms that looked just like the arms of a traditional hurricane. The storm also had a calm eye in the center. There, the plasma was still, compared to the fast-rotating outer regions. Some parts of this storm spun at speeds up to 4,700 miles per hour. It's an incredible speed compared to Earth's hurricanes. The team observed the phenomenon for 8 hours. After that, it gradually broke down. Scientists managed to identify this storm as a space hurricane only in 2021, using observations that had been made several years before. Space hurricanes have several distinct features. First, it's cyclone-shaped, massive, bright auroras that can last for hours. Then there's the eye of the storm, a calm, stable center of the hurricane. A space hurricane also creates a circular magnetic field with strong disturbances around it. Plus, scientists mention electron rains in the ionosphere. These rains are what causes those bright, colorful auroras right below the storm. But how do space hurricanes form? To understand this process, we need to first talk about regular auroras, like the northern lights. The sun emits a stream of charged particles, also known as the solar wind, non-stop. And sometimes, this wind brings massive bursts of energy towards Earth. Luckily, Earth has a magnetic field that acts like a shield, protecting us from most of this high-energy solar radiation. But when solar winds are too strong, they can get into the upper atmosphere, especially near the poles. When these particles from the sun hit Earth's magnetic field, they release energy that lights up the sky in the form of auroras. Now, in a typical aurora, electrons from the solar wind excite nitrogen and oxygen molecules in the atmosphere, which then emit light, leading to colorful shows in the sky. Space hurricanes are similar, but they happen at higher latitudes, above the region where auroras usually appear. They create a swirling, cyclone-like effect that looks quite different. Scientists are still studying the exact conditions necessary for a space hurricane to occur. But they already know that, surprisingly, such storms happen during very calm space weather. This is the opposite of traditional geomagnetic storms, which need intense solar activity. Space hurricanes need just the right balance of low solar wind and northward-pointing magnetic fields. And even though these storms are uncommon, they aren't impossible, hence those unique swirling storms above the poles. When scientists observe the space hurricane over the North Pole, they notice some shocking similarities to hurricanes on Earth. Just like the typical hurricane, a space hurricane has a central area where the plasma is calm. Even more curiously, the plasma in space hurricanes spins in a counterclockwise direction, which is like hurricanes raging in the northern hemisphere. The space hurricane also has multiple spiral arms, just like the ones you can see in satellite images of Earth hurricanes. Plus, the space hurricane doesn't need the strong solar winds that typically create disturbances in our atmosphere. No, it forms in periods of calm, just like how an Earth hurricane can only form if the winds in the atmosphere aren't too disruptive. Now, space hurricanes may be high above us, but they can still affect our daily lives, especially in areas related to satellite communications and space navigation. Those electron rains caused by the storm interfere with radio signals that travel through the upper atmosphere. It can disrupt GPS systems, radio communications, and radar systems. What's even worse, this interference can impact the orbits of space debris or space junk, which is already a problem for spacecraft and satellites in low Earth orbit. The storm's electron rain slightly heats up the atmosphere, which leads to extra drag on satellites and can potentially change their orbits. At the same time, the effects space hurricanes have on Earth aren't as direct and disastrous as those of hurricanes down here. They really don't pose any serious health risks to astronauts or damaged satellites. But researchers say that studying such storms can help improve predictions for satellite operations, especially for flights that cross polar regions. Now, interestingly, scientists didn't set out to find space hurricanes when they spotted one. The discovery was a total accident. It happened when Larry Lyons, a space physicist from UCLA, and his team were looking through satellite data for another study. In this study, they noticed unusually strong plasma flows in the polar cap, the region at Earth's poles where auroras usually don't appear. When they looked more closely, they saw that this plasma wasn't just flowing, it was swirling, creating a circular pattern with a bright auroral spot in the middle. The researchers were intrigued. They analyzed over 300 different space hurricane events that happened over a span of 11 years. These storms appeared most often in the afternoon during summer months. It made the scientists believe there might be certain times and conditions that could encourage their formation. Luckily, with new research tools and techniques, scientists have been able to identify space hurricanes with greater precision. And recently, they've spotted parallel storms happening near the South Pole as well. The most exciting thing about this research is that it might help us better understand Earth's space neighborhood and the way solar energy affects it. Scientists like Lyons believe that space hurricanes may not actually be a new phenomenon. They may have been occurring for a long time, but no one noticed them. Space plasma physicists point out that space hurricanes resemble a phenomenon people observed earlier. It's called high-latitude day-side auroras. At the same time, space hurricanes are much brighter, and they have stronger circular flows, which give them those hurricane-like arms. Understanding space hurricanes could eventually help scientists predict them. It would be useful for planning space missions and making satellites more reliable. Plus, by looking at these storms, researchers hope to create a more complete picture of how auroras behave at higher latitudes. And even though space hurricanes may seem purely like scientific curiosity, they can give us important clues about how Earth's magnetic field and atmosphere interact with the solar wind. And who knows? This understanding might even help us spot similar storms on other planets with magnetic fields. It could offer clues about magnetic storms beyond Earth. So get this, Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
It was supposed to be an easy 8-day-long mission. 2 NASA astronauts couldn't even imagine they would get stranded in space for at least 9 months. Their task was to test a brand new spacecraft, Starliner. They were hoping to return it to Earth as soon as possible so engineers could check it out and send it on a new flight. But from the very start, it didn't go as planned for Butch Wilmore and Sunita Williams, experienced astronauts who had both been to the International Space Station before. They were supposed to depart on the 6th of May, 2024, but had to postpone departure for 1 month because of a leaky valve in the upper stage of their rocket. When they finally took off on the 5th of June, new problems started before they even got to the station. There were failures in some of their thrusters and, later, leaks in the gaseous helium. It's important because it keeps the thrusters pressurized. Boeing, who built the new spacecraft, and NASA focused on solving those problems and figured out it wasn't safe for the astronauts to fly back home on the Starliner. They didn't just leave them on the ISS, of course. NASA came up with a plan where Butch Wilmore and Sunita Williams would come back home on a SpaceX Crew Dragon spacecraft. It took off in September of the same year with 2 empty seats out of a total of 4. The only problem is that it wasn't supposed to come back until February 2025 at the earliest. In a press conference from the International Space Station, Wilmore and Williams admitted it was heartbreaking to watch their spacecraft depart without them, but they were trained to expect the unexpected. They keep receiving messages of support from Earth, and they aren't at all sad to spend more time in space, as they say it's their happy place. Mr. Wilmore gets up every day at 4:30 in the morning, and Miss Williams at 6:30. They do at least 2 hours of exercise at the space gym every day to reduce the loss of bone density. Another big problem is sleeping in space. The space station has 6 tiny sleep pods, each about the size of a phone booth. Inside, there's a sleeping bag, a little storage area for snacks and personal stuff, and even 2 laptops attached to the walls with bungee cords. The pods aren't completely soundproof, so astronauts sometimes wear headphones to listen to music or calming sounds from Earth to help them fall asleep. But here's the problem. There are more astronauts than sleep pods, so 3 astronauts have to find other places to sleep. One of them sleeps in a simple backup sleep chamber inside the European Space Agency's Columbus lab. Butch Wilmore is roughing it in just a sleeping bag inside the Japanese Space Agency's lab. When they planned this mission, Butch was only supposed to sleep like that for 8 days, which didn't sound that terrible. Another problem they had to deal with was that they didn't pack enough clothes for several months. So, astronauts had to savor what they brought for the first 2 months until a resupply vehicle delivered fresh outfits along with hardware, fruits, and vegetables. The astronauts have a super packed schedule that's managed by a computer tablet. It tells them what tasks to do, when to take breaks, and even when to eat, all in 15-minute chunks. A little red line on the tablet moves through the day in real time, showing them if they're on track or running behind. At first, Butch and Williams were working on the Starliner spacecraft, testing all its systems like communications, life support, and power. Once they finished that checklist, they started helping the other crew members with science experiments and maintenance tasks. The best-case scenario is now a late March return, and if it actually happens, the Starliner crew will spend over 270 days in space. An average mission on the ISS lasts around 6 months, so it's already way longer, but not close to the record time. The current American record belongs to astronaut Frank Rubio, who stayed in space for 371 days in a row. He lived on the International Space Station from September 2022 to September 2023. When Frank first went to space, the plan was for him to stay there for about 6 months, but it didn't go as planned. In December 2022, a meteoroid, or maybe a piece of broken satellite junk, crashed into the spaceship that was supposed to bring him and his 2 crewmates home. The spaceship was damaged so badly that it wasn't safe to use anymore. The 2 astronauts who were on that spaceship also had to stay on the ISS with Frank for 6 extra months until another spaceship went to space and rescued them. During his mission, Frank Rubio zoomed around Earth about 5,936 times. Altogether, he traveled a distance of 157 million miles. It's like going to the moon and back 328 times. Frank also went on 3 spacewalks and spent 21 hours outside the space station. One of Frank's big jobs was to do scientific experiments. He studied how bacteria behave in space, where there's no gravity pulling things down like on Earth. But his favorite experiment was taking care of a tiny tomato plant and watching it grow. Frank admitted that being away from his family for so long was really hard, but it's not the only possible hardship on such an extended space stay. Space agencies have entire departments that study the effects of space on the human body. In one of the studies, called Twins, scientists compared 2 identical twin brothers, Scott Kelly and Mark Kelly. They're both astronauts, but for this study, Scott spent a year on the ISS and Mark stayed on Earth. By comparing them, scientists could figure out how space changed Scott's body compared to his twin. He said it took him at least 6 months to feel like his usual self again after coming back to Earth. Scientists noticed predictable weight loss and bone mass loss, but they didn't expect to see changes in his DNA. They found that his telomeres, which are like tiny protective caps at the ends of DNA strands, got longer while he was in space. But sometime after he got back, he had more short telomeres than before. It looks like the damage was permanent. It must have to do with radiation, which is one of the biggest dangers for astronauts who stay in space for a long time. It can damage DNA, and that can increase the risk of some really serious health problems. Astronauts need protection from radiation, not just while they're flying in space, but also if they live on the Moon or Mars someday. Scientists are working hard to find ways to keep astronauts safe from this invisible danger. Every space agency has rules about how much radiation astronauts can safely handle during their careers. Another big problem astronauts face is bone demineralization. It happens because there's no gravity in space pulling on their bones like there is on Earth. Without that pressure, their bones start losing minerals like calcium, which makes them weaker. Astronauts can lose about 1 to 1.5% of their bone density every month they're in space. When calcium from the bones gets into the body's waste system, it can lead to kidney stones. Because of these changes, astronauts coming back from space need time to recover. Another challenge in space is how the body's fluids, like blood, behave. On Earth, gravity keeps most fluids lower in your body, but in space, they float upward. This extra fluid in the head can push on the eyes, which might change how astronauts see. Some even develop a condition that can make it hard to focus their eyes, and sometimes the changes in vision can be permanent. When astronauts who spend a longer time in space, like Williams and Wilmore, return to Earth, doctors keep a close eye on their health with regular checkups. Scientists expect that their condition is going to be like that of 6-month astronauts.
In 1997, a terrifying situation, or rather several of them, happened on the Mir space station. These stations are often like houses in space, with a crew of astronauts living and working on them. Back in the 80s and 90s, Mir was a marvel of human achievement, a huge floating laboratory. But it wasn't without its dangers and horrible incidents. In February of '97, astronaut Jerry Linegar had been living and working on Mir with his crewmates. Then one night, things went terribly wrong in the Cavat-1 module. An oxygen generator, a machine that burns chemicals to release breathable oxygen, suddenly burst into flames. They were trapped in a tiny enclosed space with smoke filling the air, and there's literally no way to escape. The fire blazed for 14 minutes. It filled the station with smoke so thick the astronauts couldn't even see their own hands. They immediately reached for the gas masks, which should have been their lifeline. Unfortunately, the masks didn't work for everyone. By the time of the fire in '97, Mir was already 11 years old, well beyond its expected lifespan. The equipment, including gas masks, most likely degraded over time due to the harsh conditions of space. The Mir underwent regular resupply missions, but regular maintenance is challenging due to how costly and complex space missions are. And when they tried to grab fire extinguishers, they found them strapped to the walls too tightly to use easily. It was just one disaster after another. Luckily, the fire finally burned itself out, but not before leaving burns on some of the crew. Liniger, who was a trained physician, treated his crewmates. He also wrote a report for NASA about the incident, but NASA downplayed the event, treating it as a useful learning experience for future missions. Besides, it wasn't the first incident like that. On an earlier Mir expedition, the oxygen generator also burned for a few seconds. The investigation showed that the oxygen generator canister was contaminated with something, most likely hydrocarbons from latex gloves. And this was just the beginning. A few months earlier, in June, another incident happened with a British-American astronaut, Michael Foale, and two of his other crewmates, Vasily Sibliev and Alexander Lazutkin. Foale is fluent in the Russian language, and so that's how they spoke. Michael had heard about the previous fire, but thought that now that it's fixed, there shouldn't be any problems. If only he knew. One day, a cargo spaceship called Progress was supposed to bring supplies to the station, stuff like food and equipment. It was slowly docking, and then suddenly, it crashed into the Mir. This happened out of nowhere. The crash caused a hole in one of Mir's rooms, called the Spectre module. Air started rushing out into space through the hole. That's the most horrifying thing that could happen in space. Without air, the astronauts wouldn't have survived long. They had only 23 minutes before they would lose consciousness. Foale's ears began popping as the pressure dropped. But fortunately, they all went through NASA's intense training and were prepared for stuff like this. Michael went to the Soyuz capsule, a space station lifeboat. If things got worse, he planned to use it to escape back to Earth. He was waiting for his crewmates. But to his shock, they didn't show up. Instead, they stayed behind to find the hole and fix the station. In situations like this, it's prescribed not to risk it and evacuate. But Vasily and Alexander decided to try and save it. Michael was waiting for them, but he could hear them shouting to each other in Russian as they desperately tried to fix things. Time was running out. There was only 7 minutes of air left. And finally, they managed to seal the broken module and stop the airlink. But just as they thought they could take a breath, another problem came up. The crash had damaged the station's solar panels. In just moments, the entire space station lost all its power. No lights, no fans to circulate air, and no way to talk to anyone on Earth. And to make things worse, because of the collision, Mir started spinning out of control. It was a total catastrophe. Michael had an idea to stop the spinning. They could use engines on the Soyuz capsule to push the station and stabilize it. They decided to try it. Unfortunately, the first attempt only made things worse. The spinning got faster, but they decided to try it again, this time using short bursts of the engines. And eventually, it worked. The station stopped spinning, and they were safe again. And you'd think they'd go home after that. But even after this terrifying experience, Michael stayed on Mir for 4 more months to finish his mission. Later in 1995, he went back to space and even set a record for the longest spacewalk at the time, 8.5 hours outside the spaceship. But Mir was just getting worse. The stress of living there was so intense that Vasily Sibliev developed heart problems during that mission. Literally the same year, just a couple of months later, in August, another disaster struck. The main computer suddenly went down. This left the station just drifting in space with no control. Without this computer, Mir couldn't align its solar panels with the sun. This meant that the station's batteries were draining rapidly. In space, no power means no communication and no life support. And remember the Progress supply ship? Well, this power outage happened exactly when another Progress ship was trying to dock, just like the last time. But now, the computers that controlled the process weren't talking to each other properly. Commander Anatoly Solovyov had to take over manually. And it got wild. Because the monitors on the Progress ship weren't working, he had to use a monitor on Mir to see what the supply ship saw. It was like trying to park a car using a camera feed from someone else's dashboard. When the supply ship got just a couple of feet away from docking, the screen went completely blank. Solovyov couldn't see anything. He could only pray and guess. But miraculously, he nailed the docking. But the main computer was still down, and Mir was spinning rapidly. The crew had to save the remaining power as much as possible and stop the spinning. So they shut down all non-essential systems and ran for the Soyuz module. They decided to try what Michael did before them, to fire the capsule's engines in short bursts and push Mir back into position. They had to steer the station manually, and with no modern tools to guide them, they had to rely on the stars, like sailors hundreds of years ago. Finally, the spinning stopped, but they still only had a few days of air. After that, they'd have to rely on chemical candles, devices that burn to produce oxygen, but also carry the risk of fire. And fire, as Mir's history showed, was not something they wanted to mess with. While the scientists were trying to reassure everyone on Earth that things were under control, the crew began fixing the broken computer. This task took hours, all in darkness, because there were no solar panels. But somehow they managed to repair it. After that, the astronauts had to face the sun to recharge Mir's batteries. Only then could they even think about tackling the long list of other repairs, like fixing the still-damaged Spectre module. Mir had turned into a survival reality show. Once Mir was over a decade old, it became known for its cramped, cluttered interiors. It was full of broken equipment, leftover supplies, leaking pipes, and all sorts of odd junk floating around. The astronauts said that it was hard to move and felt like living inside a dirty, leaking submarine. Another huge issue was mold. It started growing on walls, in air vents, and even on the astronauts' personal items. Now imagine dealing with all of that in zero gravity while trying to conduct experiments. Finally, in March 2001, after 15 years in space, Mir was finally intentionally deorbited. It broke apart in Earth's atmosphere and burned up over the Pacific Ocean. Well, despite all the problems, Mir paved the way for the International Space Station that is still working to this day.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the Sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket. Space is vast, dark, and empty. So, wait, what's that? Is it a sphere? Huh? That looks like something like a whitish soap bubble floating in space. Zoom in. A bit more. Do you see people inside? They look like ants dashing around, doing their own things. Someone is growing food, someone is working in the lab. What kind of a sci-fi fever dream is this? Now, all this might not be as unrealistic as it sounds and looks. Right at this moment, Max Space is working on inflatable space habitats that could make living in space possible and cheap. Their biggest habitat would be as roomy as a sports stadium. They've already shown off their plans, claiming that such habitats could help humanity move off Earth in the future. According to one of the founders, there isn't enough living space in space. And if we don't make it cheaper and much, much bigger, we're not going to get very far in space exploration. As for expandable habitats, they are clever. At first, they're small enough to fit on a rocket, but once they're in space, they inflate to create a much bigger living area. For example, one of such habitats with around 3,500 cubic feet of space would cost way less to make than a traditional metal module of the same size. For comparison, the ISS has about 13,700 cubic feet of living space, so this is a big deal. Similar space habitats already exist. A company called Bigelow Aerospace launched 2 test modules, Genesis 1 and Genesis 2, back in the 2000s. And another module called Beam has been attached to the ISS since 2016. Sadly, Bigelow closed down in 2020. But now, Max Space is taking the tech to the next level. They're using a totally new design to make their habitats expand reliably and on a much larger scale. They're planning to test them in space soon. In 2026, they'll send up a module the size of 2 suitcases on a SpaceX rocket. Once it inflates, it'll have about 700 cubic feet of pressurized space. They've already built a full-size prototype to test on the ground and are now making the real thing for space. While this first one won't support people, it'll have the same strength and shielding powers as future human-rated habitats. Colonies on the Moon and Mars, floating space habitats. Everything seems to be all about space exploration these days. NASA, along with space agencies from Canada, Japan, and Europe, is working on something called the Gateway Program. It is basically a plan to build a space station that will orbit the Moon. Meanwhile, billionaires are busy dreaming up colonies on Mars and Venus and even launching space tourism projects. If these ideas actually work, they'd be our first step towards living in space. But there's one problem. If we want to survive out there long term, we need to figure out how to produce kids in space. Should it be natural ways? Are we going to start using special technologies? Space reproduction is super tricky, and the biggest issues are radiation and gravity. That's where Spaceborne United, a company from the Netherlands, comes in. They're working on solutions for this. They've built a tiny IVF and embryo incubator that's ready to be tested in space. Just recently, they've dropped it from about 12 miles above Earth to see how radiation affects organic materials. The CEO of Spaceborne United has explained that their goal is to figure out if conception and early embryo development can happen in space. If we're serious about settling on Mars or other planets and making those settlements fully independent, we'll need to solve this reproduction issue. For example, Mars has way less gravity than Earth, and no one knows if that's enough for embryos to grow properly. Spaceborne United is starting by studying how partial gravity, like what Mars has, might affect development. It's still early to speak about some results, but at least we've started moving in this direction. Even if we deal with the space kids problem, what about other earthly things, like plants? Photosynthesis has had a massive impact on Earth. When organisms started using sunlight to make energy, it triggered the Great Oxygenation Event. It filled the atmosphere with oxygen, allowed multicellular life to develop, and even formed the ozone layer, which protects us from the sun's harsh UV rays. Thanks to that, life was able to move onto land. But how would plants grow under the light of other stars? Our sun is a G-type star, called a yellow dwarf. It feels like a typical star to us, but it's actually pretty rare. Only about 7 to 8% of stars in our home Milky Way galaxy are like it. And since most stars aren't like our sun, scientists studying habitable planets are focusing on more common types. K-dwarf stars, for example, are smaller than our sun, about 50 to 80% of its mass. But they're more stable and last much longer, up to 70 billion years, compared to the sun's 10 billion years. That's a lot of extra time for life to evolve. Despite this, researchers have often focused on M-dwarfs, aka red dwarfs. They're the most common stars, but they have their own issues, like frequent flares. In a recent study, researchers have simulated the light from a K-dwarf star to see how two photosynthetic organisms would respond. They chose garden cress, a fast-growing plant often used in salads, and cyanobacteria, a tough microorganism that can survive extreme conditions. The goal was to see if photosynthesis would work under K-dwarf light. Then, they put watercress seeds in 3 different conditions: sunlight, simulated K-dwarf light, and no light. The plants under sunlight and K-dwarf light grew similarly, but the seeds under K-dwarf light actually sprouted a bit earlier and had slightly larger leaves. It means that plants could potentially thrive under K-dwarf light just as well as they do under sunlight. So, K-dwarf stars seem like a great option for finding habitable planets. Unlike M-dwarfs, they don't have intense flares that could harm life, and their habitable zones are far enough out that planets wouldn't get stuck in tidal locking, where one side of the planet always faces the star. K-dwarfs also become habitable sooner in their lifetimes because their harmful radiation drops off faster than that of M-dwarfs. But how about this? What if life doesn't actually need planets to survive? That's the idea 2 scientists from the University of Edinburgh want you to consider. We've always assumed planets are crucial for life because they provide the right conditions: liquid water, temperatures and pressures to keep it liquid, and protection from harmful radiation. But what if life itself could create those conditions in space? The researchers suggest that ecosystems could generate and maintain the conditions they need without needing a planet. Life could create barriers and structures to keep water liquid, let in light for photosynthesis, block harmful UV rays, and even maintain the right pressure and temperature. And all of this in space, far from any planet. These barriers could work in regions between 1 and 5 astronomical units from the Sun, which includes areas closer to Earth and Mars. Gravity and planets might not always be necessary for stable environments. Biological systems might be able to do the job themselves. Earth is a perfect habitat for life, not only because it has water and a protective atmosphere. It's also an interconnected system where energy from the sun powers everything. Essential elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur cycle through the planet thanks to such processes as volcanism and plate tectonics. Outside Earth, things get trickier. Take the icy moons in our solar system, for example. They might have warm, salty oceans beneath their surfaces, but do those moons have nutrient cycles like Earth? And can they keep water liquid or maintain an atmosphere? These small, cold worlds don't get much energy from the sun, have no way to hold on to their atmospheres, and are exposed to harmful UV radiation and cosmic rays. For life to survive beyond Earth, it would need to adapt to these challenges or modify its environment. And if their idea is true, then perhaps life doesn't just adapt to its environment. it could also create entirely new ones.
So, you wake up after a nap. You flick the light switch. Nothing. It's still pitch black. Your phone battery's gone. The charger's useless. No Wi-Fi, no TV, just static on the radio. You are completely cut off. You move to the window and see that the entire city is in darkness. Then, out of nowhere, the night sky explodes into swirling shades of green, purple, and blue. It's an aurora borealis in a place where it should never happen. So, what's going on? What sounds like a real modern-day nightmare might come true if a super powerful solar storm hits Earth, and it could cost trillions of dollars in the United States alone. So now scientists are building some kind of warning system. It's a space traffic light, helping to protect us from the hidden dangers of our own life-giving sun. Now, first things first, solar storms are giant bursts of energy that come from the sun. Imagine the sun as this big sphere, wrapped up in a chaotic mess of magnetic fields, just like your fine strands of hair after a rough night's sleep. Now, as the sun spins, those magnetic fields start to twist up. But here's the thing, they don't all move at the same speed, and that's what throws everything off balance. Because those tangled magnetic fields get stretched and twisted so much that they eventually snap and reconnect. And when that happens, boom, tons of energy gets released and races through space. A solar storm is exactly that, a sudden outburst of energy, particles, magnetic fields, and hot material thrown out by the sun. And it usually shows up in three powerful forms. First up, the solar flare. This is a bright flash of radiation or light that puts on a spectacular show. These are the most powerful explosions in our solar system. Solar flares send out all kinds of energy across the electromagnetic spectrum, including X-rays, gamma rays, and radio waves. Next, the radiation storm. This happens when the sun launches charged particles, like electrons and protons, into space at super high speeds. Just to give you an idea, the quickest particles can cover the 93 million miles from the sun to the Earth in just 30 minutes. And finally, the coronal mass ejection. This is when massive clouds of plasma explode from the sun's outer layer, known as the corona. From afar, it looks like giant bubbles popping off the sun's surface. These blasts are so strong, they can shoot billions of tons of material deep into the solar system in one powerful burst. Okay, so solar storms are blasting all this stuff out into the solar system. And that should be fine, except it's not, because it can affect us. When a solar storm is headed toward Earth, things can get tricky. If it slams into our magnetic field, it triggers what's known as a geomagnetic storm, and that can seriously mess with our daily lives. Take satellites, for example. A strong geomagnetic storm can damage them or make them shut down for a while. GPS systems, like the one in your phone or car, can stop giving accurate directions. Signals from TV might glitch or cut out. Even phone calls could drop or sound weird. On a larger scale, the internet itself could run into serious trouble. If service providers go down, all the systems that rely on the web to stay connected might stop talking to each other. That could leave countless people and businesses completely offline. Experts say this kind of internet apocalypse scenario could cost anywhere from $600 billion to a staggering $2.6 trillion in damages. And that's just in the United States alone. Radio communication might also take a hit. And that's a big deal, because during a major blackout, it's usually one of the few ways we can still get news. But the trouble doesn't stop there. It can also mess with flights all around the world. And for everyday people, that could mean grounded planes, delayed trips, and total confusion at airports. It can also send extra electrical current flowing through power lines. That sudden surge can overload transformers and knock out the power. This isn't just a what-if situation. It really happened in Canada back in 1989, for example. A solar storm left the entire province of Quebec plunged into darkness for 9 hours straight. Although powerful solar storms don't hit Earth often, they can and do happen. In fact, one struck in May of 2024. You might remember the news. Social media was flooded with photos and videos of strange auroras lighting up the sky in shades of green, red, and blue. But the wild part is that these auroras showed up in places where they're not supposed to. People in countries like Brazil, South Africa, Turkey, South Korea, Spain, and many others got to see this stunning sky show for the very first time in their lives. And all of that happened because of a solar storm, the Gannon storm. Yep, when a solar storm is strong enough, it pushes the auroras far beyond their usual zones, making them visible in places much closer to the equator. Now, although they're still considered rare, powerful geomagnetic storms are happening more and more often. That's because the sun is experiencing what's called the solar maximum. Basically, it's a peak in solar activity that happens about every 11 years. So, when's the next big solar storm going to hit us? Well, maybe soon. NASA says an event like that could happen sometime in 2025. It might strike next week or maybe a few months from now. But here's the tricky part. No one knows exactly when it will happen. It's tough to predict it because the sun is complex and always changing. So there is a lot of uncertainty around the speed and direction of solar storms. That's why we've got satellites floating about 1 million miles from Earth just to keep an eye on them. But here's the problem. When a big solar explosion happens, it can reach Earth in just 1 day. And since our satellites are still pretty close to us, we only find out the important stuff, like the direction of the magnetic blast, perhaps only an hour before it hits. And that's barely any time to act. It makes it super hard to prepare and protect things we rely on every day, like power lines, internet service, phone networks, and satellites flying above us. So today, we're just hoping for the best. And that brings us back to why we need a traffic light system to protect us from solar storms. The main goal of the Pager project is not to predict when the storm might hit, but also to understand how bad it could be and what kind of damage it could cause here on Earth. This traffic light will be an algorithm. It will collect information from telescopes watching the sun and from satellites orbiting Earth. Then it will feed that data into advanced models. These models can predict how much radiation is in space, how it might affect spacecraft, and what kind of impact it could have down here on the ground. This will also help satellite operators decide if space conditions are safe or not. Just like your local weather forecast tells you if you might need an umbrella. This system will do the same for satellites, warning them when it's better to power down or stay protected. But the main idea is that this tech could give us a heads up way earlier about dangers coming from the sun. With these traffic light calculations, we might know when a solar storm is coming and how strong it will be up to 2 days in advance. That's a big deal, because this will finally give us a chance to be better prepared for the next one. This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, this signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss, because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So, when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now, these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So, even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our Sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom! We've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, This means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future.
You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olbers' paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky, it's not empty. It could be that it's full of light we just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be, But you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them, and a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, isn't it possible someone else did the same, like 150,000 years ago or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature, black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, it disappears behind the event horizon. And then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say, maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models, so it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with 2 holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways, but in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality, and that's what makes it so exciting. See you next time!
Now, you've seen those breathtaking images from NASA. Stars born in clouds of gas, tangled galaxies, colors that look fantastic and vivid. And then someone suddenly says that this isn't real, that NASA edits all these pictures. Well, guess what? They're right! NASA does edit their photos, every single one. The catch is that it's not to deceive us, but rather to reveal what we could never see on our own. You see, color is a weird thing. It's just waves of light and energy flying through space. When these waves hit some object, a banana, a chair, or even a dust particle, the objects absorb some of the waves, eating a part of the spectrum. But some of it bounces back into our eyes. That bounced light is what we perceive as the object's color. There's an entire spectrum of these waves, from short ones to long ones. As they get longer, they move to the red spectrum and turn into infrared, microwaves, and radio waves. As they get shorter, they move closer to blue and violet, turning into ultraviolet, X-rays, and gamma rays. Now, right in the middle of that spectrum is a tiny band we call visible light, which is the only part our eyes can see. That's the rainbow we all know and love, and it's an exceedingly small part. So, you might say we barely see the world at all. When light bounces off something and gets into our eyes, our color-detecting cells, called cones, send them to our brain. So, when we say, banana is yellow, it means banana ate red, green, and blue waves and reflected yellow waves into our eyes. So, the question is space actually that pretty and colorful, or is it all fake? Well, yes and no. Stars emit light, and it travels through space like an unstoppable train. It's flying there, chilling, until it hits something – dust particles, a planet, spaceship, or an astronaut. Every time light hits something, some of it gets absorbed, some of it reflects and continues to travel. So we get less and less light every time it hits something. And when you enter a nebula, which is basically tons of dust particles around a gas cloud, light quickly starts to scatter and disappear. Nebulae, which is the plural of nebula, also grow naturally from ionized gases like hydrogen, oxygen, sulfur, radiating light in specific spectral lines. But it's super faint as well. Remember, our eyes see things only when light bounces off those things in our eyes. On top of that, the color-detecting cones in our eyes aren't so great. in that they need lots of light to activate. We can't see faint stuff. Unless there's something emitting light right there nearby, we wouldn't see anything. In other words, for us, the entire space would be like a room with lights turned off. The potentially beautiful nebulas and planets are there, but if you don't have a lamp nearby, you can't see them in all their glory. When there's lots of light around, rods take over, another type of cell that's great for motion and dark vision, but terrible for color. So in deep space, all we'd see are dim whites and grays. Now, if you were flying around on a spaceship, the stars would look sharp, white, and non-twinkling. You'd be able to see some reddish or bluish tints to the brighter ones, like Betelgeuse or Rigel. But a lot of things would be dim gray smudges at best. The Milky Way might appear as a cloudy band, not rainbowy like in astrophotography. Nebulae would look like faint fuzzy clouds with no color, unless it's something that glows very brightly, like the Orion Nebula. In our solar system, astronauts can see stuff thanks to the sun or when they're near illuminated planets or spacecraft. Planets like Jupiter and Mars retain some color for our eyes. Meanwhile, on Earth, the sky would look black during the day if we had no atmosphere. The sun would be a bright disk in a void as seen from the moon. If only we had super-sensitive cone cells that could detect light better than we do and see even faint things. Oh wait, we actually do have technology for that. Long-exposure cameras and telescopes. Now, telescopes are great for that. They often use long exposures to gather light over minutes or entire hours. That lets them capture photons we'd never collect with our eyes. When telescopes like Hubble or the James Webb take photos, they're not snapping pretty pics like those on Instagram. They're collecting all this raw, invisible data, numbers and faint light that's both within and beyond human vision. The James Webb Space Telescope doesn't even see visible light. It's built to detect infrared or heat. Telescopes like that work like time machines. They show not only distant galaxies, but also what those galaxies looked like billions of years ago. We see stars that have long since gone out, and galaxies that may have already disappeared. All because the James Webb can pierce through gas and dust and see galaxies so old that their light has been stretched into infrared wavelengths as the universe expands. In other words, this telescope isn't made to let us take aesthetic photos. Its main goal is to study the history of the universe. Now, at first, this stuff looks like grayscale or even black images. When the James Webb sends data back, it looks empty. But during post-processing, astronomers map wavelengths they received to visible colors. Every color in those pictures is chosen for a reason. It highlights specific wavelengths, gases, or temperatures. In any case, it shows what would otherwise be completely hidden from our eyes. Sometimes they show only stuff a human eye can see. Sometimes they shift colors or add something to show elements or intensities. For example, let's say you're studying a supernova, a star blowing itself to pieces. You need to see its debris clearly to understand what's going on. That means you'd play with the contrast or adjust color balance to reveal specific gases and find pale objects near bright ones. Want to check out a weird rock on Mars? You zoom in, adjust the lighting, boost the shadows. Photographers do this every day. So scientists do it too, because clarity means understanding. Even old photos from the Apollo missions have been touched up in modern times. It's like restoring an old film so it looks crystal clear instead of foggy. Without this editing, the most incredible discoveries of the past 2 years, those first galaxies, those newborn stars inside cosmic clouds, would just look static. Is it possible to accidentally misinterpret the color? Of course! For example, images we get of Mars are mostly red, but when we land on a planet, it's more colorful. Most of it is gold, yellowish, tan, or brown. The reason Mars looks reddish is due to rusting iron in the rocks, Martian soil, and dust. It all depends on the lighting, atmospheric dust, and image processing methods. But the fantastic colors themselves are not made up. Galaxies contain billions of stars, gas, and dust, giving off incredibly rich color ranges. NASA's photos are basically translations. Now here's an interesting take. Could we use goggles with night vision or some technology that makes our eyes notice light better, like working with Hubble or the James Webb? Man, the sky would be insane. You'd never be able to sleep again. These magical astronomy glasses should greatly amplify faint light, enhancing and translating colors. Unfortunately, today's night vision tech won't cut it. Night vision goggles work by amplifying visible and near-infrared light, but they display everything in green monochrome, not true color. Meanwhile, infrared goggles detect heat, not color. We need some goggles that raise photon sensitivities by 10,000 or so. If only we were lucky enough, like some animals. For example, snakes can see infrared, bees see ultraviolet light, and birds see more colors than we do. And we can't even imagine how they perceive the world. So yeah, NASA edits their photos, because raw space isn't built for our eyes. It's dark, cold, distant, and silent. But with a little translation, some math, some color grading, some visual storytelling, we can see the invisible. We can study the past and inspire more people to study space in the future.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals. And it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby, gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush, because apparently precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Karman Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.
A chunk of rock from a different star system is heading straight toward Earth at a speed 1,000 times faster than a Formula One car. And I'm not talking about some sci-fi movie plot here. Recent research shows that our sweet little Earth could be more exposed to galactic intruders than we believed. These are called interstellar objects, or ISOs for short, and there is a certain part of Earth that has higher odds of getting hit. And we'll get back to it in a minute, But first, let's see what these ISOs are all about. We've only spotted a few so far, like One-Eye Oumuamua back in 2017, Two-Eye Borisov in 2019, and this year, Three-Eye Atlas, the third confirmed interstellar visitor, passed through our solar system. Interstellar objects like Three-Eye Atlas and Oumuamua aren't gravitationally bound to the Sun or any star in our solar system. That's why they're super fast and drift freely through the galaxy until they, by chance, cross our path. But what if one of those does more than just pass by and actually hits us? Scientists ran giant computer simulations with billions of fake interstellar objects flying around, then narrowed them down to the ones that could hit Earth. It turned out that these objects wouldn't hit the planet randomly. Low-latitude zones near the equator are more likely to get smacked. Places just above or below the tropics carry the biggest risk. And before you sigh with relief because you don't live there, there's also a bit more risk for the northern hemisphere, where almost 90% of the human population resides. It's likely to happen in a pattern and not as a random lottery because ISOs are not typical orbiters like asteroids or comets tied to the Sun. They come flying in on hyperbolic trajectories. That's a fancy way of saying they're unbound, just passing through. That means their arrival direction, speed, and relative motion all matter. The simulations show many ISOs are coming roughly from the direction the Sun moves in the galaxy, or along the Milky Way's main disk, called the galactic plane. Looks like the risk of impact also changes from season to season. The fastest potential strikes lean towards spring, when Earth is moving toward the solar apex. But overall, even calmer, slower ISO impacts are slightly more likely to happen in winter, when Earth faces away from that motion. It doesn't mean you should panic. These events are extremely rare, but it changes what we imagined. Astronomical visitor from the stars is no longer just a fantasy. It's a real risk, with a map. And this isn't just theoretical. Earth already gets hit by objects from inside our solar system all the time. Space rocks, comets, asteroids, they cross our orbit. That's why scientists keep an eye on near-Earth objects. Asteroids and comets that come within 30 million miles of Earth's orbit get that title and make it to the NEO list. To track them, scientists use a whole network of telescopes on mountains, in deserts, and even in space. NASA's Pan-STARRS in Hawaii scans the sky every night like a giant radar, takes picture after picture, and compares them. If something moves slightly between the images, that's a potential asteroid. The Catalina Sky Survey in Arizona does the same thing, and it found more than half of all near-Earth asteroids we know today. There's also NEO-WISE, a space telescope that can spot dark, cold asteroids that ground-based telescopes might miss. And then there's DART, NASA's first real test of asteroid deflection. In 2022, NASA actually hit an asteroid on purpose to slightly change its orbit. The asteroid wasn't dangerous, but the test worked. And that single mission proved humanity can literally change the path of a space rock if we ever need to. And if all of this wasn't cool enough, NASA is building a new superhero to protect the Earth, NEO Surveyor. It will be the first telescope ever built specifically to detect huge numbers of asteroids and comets that could be dangerous to Earth. Here's why this thing matters so much. The solar system is crowded, messy, and full of objects we can't see with normal telescopes. A lot of asteroids are dark, like charcoal dark, and they barely reflect sunlight. That means regular optical telescopes look right past them. But even the blackest asteroid starts to warm up when the sun hits it, and warm things glow in infrared. That's where NEO Surveyor flexes. Its ultra-sensitive infrared detectors don't care how dark an asteroid is. If it's heated by sunlight, the spacecraft will spot it like a space detective with thermal vision. And the best part is that NEO Surveyor will finally see the asteroids that come at us from the direction of the Sun. Ground-based telescopes can't stare at the Sun unless they want to go blind, so anything approaching from that direction is basically sneaking up behind Earth wearing cosmic camouflage. NEO Surveyor fixes that. It will also catch the sneaky objects that travel ahead of Earth or behind us in our orbit, the ones that are drowned out by sunlight and slip through the cracks. These are real threats, and bigger telescopes on the ground often miss them. But when they don't miss a new object, they track it for days or weeks to figure out its orbit, basically its path around the Sun. They need to know if it's going to cross Earth's orbit, if it will come close, and if so, how close. If it doesn't look harmless, it will go on to the Sentry Risk Table, which is basically Earth's cosmic watch list. So, stuff hits our atmosphere all the time. Tiny meteoroids, something like cosmic crumbs, burn up and give us shooting stars. Sometimes a slightly bigger rock shows off and creates a bright fireball. It happened over northern France a couple of years ago. Astronomers spotted a small asteroid hours before it arrived, and people on the ground got a surprise fireworks show courtesy of outer space. But every now and then, a rock comes in that's not quite big enough to survive the descent, but still large enough to release a terrifying amount of energy when it breaks apart. One example of those was the Chelyabinsk meteor. On February 15, 2013, the locals were just starting their day when the sky suddenly lit up. When it blew up about 14 miles above the ground, it released the energy of 440,000 tons of TNT. Then, a space rock, only the size of a house, slammed into Earth's atmosphere at 11 miles per second. And for a moment, it looked like a sci-fi movie had come to life. The shockwave shattered windows across almost 200 square miles, damaged thousands of buildings, and injured more than 1,600 people, mostly from flying glass. And because it came from the direction of the Sun, no telescope ever saw it coming. The crazy part is that it wasn't even close to the kind of destruction a bigger asteroid could do. NASA's planetary defense experts still talk about this meteor like it was both a warning shot and a wake-up call. After this episode, NASA and international partners launched the International Asteroid Warning Network and the Planetary Defense Coordination Office, the folks whose job it is to make sure Earth doesn't get surprised smacked again. NASA is planning rapid response missions to study any asteroid that looks suspicious, and they might even send a spacecraft to check out an asteroid making a super close pass in 2029. Think of it as our planet doing regular health checkups against space hazards. The odds for any person, anywhere, to be hit by an interstellar rock in their lifetime are still minuscule. But what used to seem like science fiction, rocks crossing between stars randomly hitting us, now looks like science fact, or at least science possibility. So the more we understand how asteroids respond to impacts, the better our chances of saving Earth one day. Because you can't protect humans from a dangerous asteroid if you don't know it exists. The equipment that's getting more and more advanced gives us the advantage of time, and in a cosmic emergency, time is everything.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with two blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, My Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old. And from what we can see, one mysterious star, HD 1140283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is. At least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space. Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT-041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part: they're considered the basic building blocks for life. Imagine that, life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are two things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course. But you can glue Velcros into daily stuff and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I mean, I understand you. Some people are attached to the toilets in their homes, and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well: a laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth, but it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers.